This puzzle is called Rotten 3 by MummaBear. I got it from the Sudoku Testing Submissions channel on the CTC Community Discord. Let's go over the rules real quick. So the same colored areas, like all the greens or all the pinks, are almost clones of each other. Instead of being straight clones, so let's say this was an 8. If these were straight clones, this would also be an 8. But instead, the rules say have a rot 3 applied to them. I'm not sure what exactly that stands for, but it's effectively add or subtract 3 while also, what's the word, like, I know like in playing cards, I think you call it rounding the corner, but I don't know for this. So if this is 8, this could be 2 or 5, because 8 would be, plus 3 would be 8, 9, then 1, then 2. It goes from 9 to 1 or 1 down to 9. Another way to think about this would be think about modulus. If you divide 8 by 3, you have 2 remainder. If you divide 2 by 3, you also have 2 remainder, and same for 5. So the same relative cell in the same colored areas have to not be the same, but have the same modulus 3. Yeah. So the next rule is the killer cages. Actually, let's remove this so I don't forget about it. I did do that once on a puzzle. I just accidentally left in some digits, and then I screwed myself up during the solve and had to cancel the video. That was too bad. Yeah, so the killer cages, just the digits inside the cage add up to whatever number is given. Yeah, just sum to the top left. So these digits have to add up to 6. These have to add up to 24. Then we have the diagonals. And normally Little Killer goes all the way across the grid, but in this case, it's only for this box, or the first box. I think this is only different for this cage, yeah. So these 3 cells add up to 20, these 3 cells add up to 9, these add up to 7, add up to 7, these add up to 16. Pretty straightforward, I think. The almost clone rule seems complicated, but I don't think it is actually that complicated. I don't know. We'll see. I'm not sure how hard this puzzle is. We'll have to, you have to judge it from the length of the video, I suppose. Let's get started. I think I said the link is going to be in the description. I don't know if I said that. I say that every time, so it kind of runs together. So there's a few kind of gimmies here. So like 1, 2, 3 is the only way to add up to 6 and 3 digits. 24 is 7, 8, 9. That does actually give us one thing. So what could these 3 be? Well, they can't be 7, 8, 9. Because, let's say this is a 9. Let's just say it's like this. So this digit would have to be a 3 or a 6. But it sees a 3 up here, so this would have to be a 6. This 8 has to be 2 or 5, but it sees a 2, so this would have to be 5. This digit has to be 4 or 1, but it sees a 1, so this would be 4. So obviously we don't know the order of these digits. This is, mixed up some way. But I think these have to be 4, 5, 6, since they can't be 7, 8, 9, and they can't be 1, 2, 3. Which then make these 1, 2, 3, because it can't be this, like, the 7 digit, where let's say this is 7, this is 4, now this digit has to be remainder of 1, but can't be a 7 or a 4. So it would have to be a 1. Okay, so that's some progress, and this must be 7, 8, 9. Okay, this is going to loop around. This is interesting. So this is the same exact situation as down here. I feel like this is going to be, I don't know. This is going to be something. So this is 7, 8, 9. So this needs to not be 7, 8, 9, and also not be 1, 2, and 3, because it sees 1, 2, 3 in the column. So this is 4, 5, 6, and then again this will be 1, 2, 3, the same way this became 1, 2, 3. And then we can just do regular Sudoku, and this becomes 4, 5, 6, and this becomes 7, 8, 9, because we have 1, 2, 3, 7, 8, or 4, 5, 6 in the column. And we actually get our first digit here. The only way to make 7 in 3 digits is 1, 2, 4. Oops, 1, 2, and 4, and 4 must go there. That's the only option that matches in both sets. So then this has to be a 7, this has to be a 1. whoops, we can remove some options here. Now this can't be a 1, and neither can that. These can't be whoops, these can't be 7s, and these can't be 4s. Okay, so these are 7 and 9. How's that gonna... So these can't be 7 and 9, but they already couldn't be 7 and 9. I guess these could be 1, 4, 3, or 6. Yeah, I think so. That makes somewhat sense. Oh, and I forgot to... And these are also 1, 3, 4, 6. And I forgot to, I guess, I don't know, propagate was the word that came to head for... Oh, actually, no, these are... At least one of these is given. They're not given, but we can discover it. I don't know what to say. So this is... theoretically 4, 7, 5, 8. Yeah. But the 7 and the 8 rule out the 7 and 8 here. So we have a 4-5 pair. So then this must be a 7-8 pair because it can't be the 1-2, can't be the 4-5, so it must be 7-8. So we actually have a X-wing here on 7s. So we could ask, where can 7 go in row 3? It can't go in green because we just put 7s up here. It can't go in blue because we just put the 7s in blue up there. So one of these is a 7. We haven't used the 9 yet. But any of 4, 5, or 6 could be used. Oh, the 20. Oh, the 20 clue. That's where we need to look. I wasn't thinking about that. Yeah, somehow I looked at the 16 and 7 and the 9 and immediately saw that those were clues that, like, they existed. But this 20 clue is clearly where to go, and I didn't even think about it. So, the only way to make 20 once we have a 2 or a 3, yeah, once we have a 2 or a 3, it must be 3, 8, 9, because 2 would require 9 and 9. And that won't work for a number of reasons. Like we've already said, this is a 7 or an 8 for one, but also you can't have 2 9s in a box. So it must be like this. The 3 forces this, and then the 8 must be this way. Okay, now we have to, I guess propagate, that was the word I came up with for this. Propagate this down, and then propagate these along. So this is the remainder 2s, and that's the remainder 1s. This can't be a 1 then, this can't be a 6, this can't be a 4 because of this, so this can't be a 3. This can't be a 4, so this can't be a 3. These two, oh, that does something. These two can't be 5s, but more importantly, these 3 can't be 6s. So this is a 4. Oh, wait a minute. Did I do something wrong here? Let's back up a moment. This can't be a 1 or a... This couldn't be filled. I think did I type in the wrong digits, maybe? This must be 7, 9. Wait, let's just leave this for a second. Do I feel like I made any mistakes with this logic so far? This could not have been 1, 2, 3. This must be 4, 5, 6 because this is 7, 8, 9 and it sees a 1, 2, 3, which makes this 4, 5, 6, which places the 4 there, and these must be a 1, 2 pair. That leaves 1, 2, 3 here, and the 3 is forced to be up there to let this make 20, which then puts an 8, 5, 2 are the same, 7, 4, 1 are the same, 7, 9, which I guess we could resolve because of the 7 over here, is the only way to make 16 and 2. Therefore, blues here, this one, I guess we know what this must be. Oh, that's what I was doing wrong. For some reason, I thought these added up to 7. That was silly of me. Okay, yeah, I was just doing a silly. So this must be 3 or 6 theoretically, and I could have actually figured this out earlier. This must be a 3. This must because it can't be a 6 and it can't be the 9. And this must be a 1 because it has to be the same, I don't know, modularity as 7, but it can't be a 4. So this is a 1. And then over here we have, uh, what do we have? We have 6 because it needs to be not be 3 or 9. And we have 4 because it can't be 1 or 7. Okay, now we have a lot of reductions we can do actually right here. These can't be 2s, these can't be 3s. I've been kind of slacking on just doing basic Sudoku, I think. These can't be 9s, these can't be 8s. These can't be 6s, these can't be 5s. Okay. That might be most of them, hopefully. Okay, so this 6 looks up here. This, whoops, must be a 6. Which I guess then makes this a 3, and which makes this a 9. Oh, I was gonna say we could copy these pencil marks even, but I don't think it's helpful because this could be a 1 or a, one of these is a 1 or a 4, and one of these is a 1 or a 4. I don't think that's quite helpful yet. What about, oh, I didn't copy this 9. This must be a 6 because this box already sees a 3 and or has a 3 and a 9. This must be, I'm gonna guess that this little killer clue is just, because this clearly says the 20 clue applies to the diagonal. Yeah, let's just, actually, let's just make this a small 3. I want to have conflicts in case I like accidentally type a 9 there. I want to have it show me that. So we'll just make this dark green and say that, remember to fill that in at the end. But I think what they should have done when they set the puzzle was make this a cosmetic little killer clue rather than a functional little killer clue, because um, of course it'll work like normal little killer clues if you do a real little killer clue. Little killer clue is quite the tongue tire or whatever the. So anyway, this is a 4-5 here. So this is, I guess we can just look at whatever digits are left. This is a 1 or a 2. This is a 7 or an 8. Okay, 9. So this, well, this can't be 1, 2 for a few reasons. So could, hmm. Well, okay, so 9 triple has to have a 1 or a 2 in it. Because it's either 1, 2, 6, 1, 3, 5, or 2, 3, 4. So no matter what, it's going to have a 1 in it. And in fact, it can have at most 1, 1, or 2. Sorry, I said it must have 1. It must have a 1 or a 2 in it. And this middle cell can't be a 1 or a 2. So this is a 1 or a 2. So this is a 5 or a 6. Is that, no. Sorry, a 4 or a 5. 4 or 5 plus 3, but it can't, because it can't be 7, 8 because we already have those in the box. And then this must be a 7 or an 8. Okay, so if this was, this could be 1, 3, 5, or 2, 3, 4. So either way, we're going to have a 3 in the middle. So this has to be 6 or 9. We already have a 9, so that's a 6. So this is the 9. What's left in this row? We have a 4, 5 here, and we actually have a 4 in the column. So this is a 5, this is a 4. So this is a 1 or a 7. We have the 7 and the 4. This must be the 7 as the last of the triple. Let's look at the 5s. This is a 2 or an 8. We have the 8 and over here. So this is a 2. This is an 8. Okay, that, for some reason I felt like that was going to give us something else that I didn't notice. I don't know. Okay, so where can 7 go in this column 2? It can't go here because of this 7, so one of these is a 7. I don't know if that helps. So one of these is a 4 because we already have the 1. And one of these must be a 1. No. I think that's going to be true, but I don't think it's necessarily true because theoretically this could be Wait, I don't. Yeah, I'm not sure how constrained this totally. If the, no, if this is a 7, then this couldn't be a 7. I'm not sure. I feel like it, so. The thing I was questioning, if could this digit here double up effectively, or probably this digit here double up and take. No, but these can't both be 7s. But they don't both have to. I don't know. I'm confusing myself now. If like a 4 here could double up or do double duty for these, or could both of these pencil marks be satisfied by this? But I don't think so because they can't both be 7s. Yeah, I think so. I think I'm fine to keep pencil marking, but I think there's probably something more obvious that I can do. Let's look at this column. Where can a 4 go? Oh, of course, this is literally the same pencil. My gosh. Like I try to step back away and look at a different part of the puzzle, and it's literally the exact same thing. Okay, well, let's look right here. Oh, and ones can go down here because of these ones. So where can ones go in this column? Well, there's a 1 here, so uh, one's over here. And then down here, I think probably 4s. Yeah, 4s look. Whoops, 4s look down here. So what can this cell be? Can't be 1, 2. There's a 3 in the corner that I haven't typed in because it'll make everything look wrong. Can't be 4. Could be 5. Can't be 6. 7. Could be... No, it can't be 8 because we have the 8. So this is just a 5, which makes this a 4. So this is 7. This is 1. And now we have... what do we have? We have a 1. Why is this hard? 3. Why is this hard? 7, 9. And this must be a 2 or an 8, so it must be a 2. So this must be the 8. And this is a 4, 6, which is going to give us the last digits in the column. This must be a 2, so this is a 5 or an 8. It can't be a 5. This must be the 5, which is going to look over here, give us a 4, 5. So this is 1, 2. This is 7, 8. Oh, and this 4 is looking over, so this is 6, 4. This is the one there's on top, and then this is 7, 9. This is... What's left is 3, 5, and then the 5 fixes that. So this is 5, 3. So this is 2 or 8. This is... the 2's already over here. This is a 6. This is a 9, because we've already used 3 and 6 in the corners. And this is a... 8, not 8, not 5, is a 2. Okay. Now what? Oh, this is what the 9 is for. I was gonna say this is a super deadly pattern, or 3 different deadly patterns. I think, yeah, 3 different deadly patterns. There's no way to resolve all of these, because this could be like 7, 9, 8, and then this would have a valid answer, or you could flip them around and have this be 8, 7, 9, and that would also be a valid answer. But this 9 disambiguates that. Must be the 5, so this is 5, 6, 4. So we have for pinks we have 1 in the middle, which makes 7 in the middle. 8, 9. Which then resolves this. This is 7, 9, 8. We have the 1s up top. And this is 1, 3, 2. Oh, and then the 3, of course, is going to say it's wrong, but it is, I think this is correct. Let me look. I think this is correct. So that was pretty easy. It did take me a little bit of time because I think that it was just a straightforward set of clues with the almost clones, but it was also kind of hard to wrap my head around at the start. But that was a very nice solve, very smooth from clue to clue. Figuring out the kind of the way that the 1, 2, 3s and 7, 8, 9s propagated, and then starting to incorporate some of these clues. The 7, and then was it then the 20, and then the 16, or maybe the 16 was first, or second, I don't know, somewhere in something like that. Then we could fill in everything except for what needed the 9 clue. Yeah, that was a great, pretty linear solve. Yeah, I enjoyed that. That was a very interesting idea. To like have the almost clones. I'd like that. So thank you for the puzzle, Mama Bear, and thank you guys for watching.